Okay, on page 6, make this change. Instead of putting trick-or-treaters in this box, I want you to make this hours. However, it's still X. Okay? And then I make this trick-or-treaters, but keep it Y. If it's a little tight to fit in there, it's okay. Minor, but it's important. And the reason why I made that change too is whenever you do a line graph or usually time should be along the x-axis, whether it's hours, days, minutes, years. You usually want to plot those along the x-axis. It just makes more sense. In science also, as you'll see. Okay. So read through the opening, the introduction to the word problem, and let's figure out what our first ratio is going to be, because that was actually a problem yesterday for period 2. Read through it. I want to know what the first ratio should be in the ratio table. They had trouble with that yesterday. Val, how many say 15 to 1? How many say something different? What do you say? How many say 1 to 15? How many say something different? How many say 2 to 30? Something different. See, we're kind of all over the place. Here's your K. That's your VIP. What's the first ratio? Nick?
2 to 30.
JFR?
It's 90 to 6.
Holy cow. Guys, 15 trick-or-treaters per hour. That. 15 to 1 or 1 to 15. 1 hour, how many trick-or-treaters in that first hour? Now complete the ratio table. Yes?
But it says how many trick-or-treaters to expect.
We're going to use the coordinate plane to figure that out. Because when you fill out your equivalent ratios only go to 5. But the coordinate plane will get us our 6. That's the kind of the point of the lesson. That's what it should look like right now. From there, make your coordinates or your ordered pairs. And as a quick review, what's your multiplicative structure? Joe? Multiplicative structure times what? What's your value of your ratio? Ange. All right, good. How many sets of ratios or how many sets of ordered pairs do we have?
5.
We have 5. When you go to the coordinate plane, and this was an area also that I feel like I need to reteach. Don't do this yet. If I do all 5 sets of data or all 5 ratios, all of my data lies over here and all this other space gets wasted. So I have to figure out how do I reasonably spread this out enough so where I'm using, I'm not going to say all the boxes, but most of them. It's what we call determining the interval of your coordinate plane. What do you think, Nick?
Every 3.
All right, he says every 3. Let's just see how that's going to lay out for a minute. And again, don't write anything yet. Let's just take a look. Here's my 0. That would be first ratio, second, third, fourth, and fifth. That looks reasonable to me.
I already.
Okay? Other way to figure it out is look, count the number of boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I got 21 boxes, right? I got 5 data points, 5 ratios. I could probably do it every fourth box because 5 times 4 would give me 20 boxes. But it doesn't give us enough room to extend the line. So let's stay with 3. That's reasonable. Once you've determined your interval to be 3 along the x-axis, you've got to stay with the same interval on the y-axis. So make your tick marks every third box going up. And count carefully because you can make mistakes. All right, what's the label for the x-axis? Dylan. Label it and then start putting in your numbers. Don't worry about the 6th yet. Ange.
Is it okay if we do it every one box, like the instead of doing it?
If you count every one box, you wind up over here and everything's crunched up into one corner. I want you to spread it out. And it also helps us too to see ratios in between. If it's too crunched together, then you've got to try to figure out half boxes, quarter boxes, and third boxes. And you want to maximize the space as much as you can. That's one of our essential 180 words this week too. Okay, going up. Counting by 15s, right. Not a whole lot of room on mine here, but definitely not going to be room for a label. And even though I don't have room to fit it, what should be the label? Chris?
Trick-or-treaters.
Trick-or-treaters is correct. Then plot your points. And I'll hand out rulers while you're plotting. All right, did you connect? When you connect, then extend your line past the actual last data point. And from there, you should be able to figure out the missing value in the ratio that they are requesting. This becomes your line for 6. And what do you get, guys, if you trace it up? Matt. Sounds good to me. Okay. Are you guys comfortable with this? The hardest part is getting the interval. You want to try to use as much space as you can, because if it's too tight, because look, well, this is what's going to happen, and I'll show you, Tristan, here's an example of why we want to do it. What if I were to ask you, how many trick-or-treaters at 1 hour and 20 minutes? Still a hard question, even with the proper interval. But this is 1 hour and 20 minutes. If you count every box is 1, then you're splitting that box into thirds, and it's kind of hard to see it. However, that could be tricky. Oh, no, actually it's not. No, it's not. Works out well. What'd you get, JFR? 20, see, yeah. Because these are counting now by 5, which is great, and these are counting by 20-minute increments. And it works out. So whereas if you count every box, that might be a little bit more difficult to see.
Yeah, I wouldn't normally do this, but you just said to do that now, and I
Right.
did all this stuff.
Yeah, I'm not going to make you erase it. Be aware of it for next time. And I can work it in reverse too. Let's try this. Let's say 70 trick-or-treaters after how many hours? 70 trick-or-treaters after how many hours? I was hoping to see more hands on that. Come on, you could do it. First thing that you can do is figure out where 70 is, trace across where the line intersects, and then trace it down. Lee?
After 4 hours and 40 minutes?
Correct, 4 hours and 40 minutes. If I trace it across, hits the line here, trace it down, and remember these are now 4 hours and 20 minutes, 4 hours and 40 minutes, 5 hours. All right, one more, see if you can do it. How many trick-or-treaters at 2 hours and 40 minutes? All right, I got it. Dylan. I got 40. Did you get 40? All right, very good.